Welcome everyone. In this video lecture, we will solve a GATE 2024 EC question in which we have to estimate the differential equation using general form of the complementary function of a differential equation. So, in the question, the complementary function of a differential equation is given. So, we have to find the differential equation. So, the question is the general form of the complementary function of a differential equation is given by yt equals to at at plus b in bracket e to power minus 2t, where a and b are the real constant determined by the initial condition. So the corresponding differential equation is okay. So these are the four options. So this one is basically a question based on the second order homogeneous equations. Okay. So in this thing, before discussing this one, so we have to know some basic concept. Okay, so here it is given the yt equals to at plus b e to the power minus 2t. Okay, so here this is the solution of a differential equation having common root. Okay, so this one is question based on the two real double root. Okay, and both root are common, or simply say the common root problem. Okay, so before that I want to show you some basic formula that we have to know. For example, a differential equation second order homogeneous equation can be written as y double dash a y dash plus b y equals to 0. So in this case, if we consider case 1, if two distinct real roots, okay, so say I am saying lambda 1 and lambda 2, so the solution will be y equals to c1 e to the power lambda 1 x plus c2 e to the power lambda 2 x. So this one is our important result when the two roots are distinct and means two different roots lambda 1 lambda 2. Okay, but here in the question this one is a root of the common root problem. Okay, so for this one the solution, so now the case 2 I am writing. After that we will solve this problem. Okay, case 2, when roots are common means I am saying lambda 1 equals to lambda 2 equals to lambda. So in this case the solution will be y equals to c1 plus c2 x into e to power lambda x. Okay, here our y dash is our dy by dx. Okay, but in question dy by dt, so we can transform this thing, so no need to worry for this thing. Okay, here this we are considering y dash is dy by dt. Okay, so this one is the for the common root problem. Okay, one more thing is there for the complex root also, so I am also writing the formula only. For more detail you can go from any mathematical, but these are the basic things, so I am just first writing the all formula. Okay, so pencil I have to select. Say case 3. Okay, when roots are complex conjugate. So in this case, when the roots are complex conjugate, say lambda 1 equals to something, say minus a by 2 plus I omega, or lambda 2 equals to minus a by 2 minus I omega. For example, I am saying these are two roots. Okay, then the corresponding solution will be y equals to e to the power minus x by 2. Okay, then we can write as a cos omega x plus b sine omega x. For more detail, you can also follow the book, namely the engineering mathematics book by Irvin Krejcik. Okay, Irvin Krejcik is one of the very famous book. So for the complex conjugate, this one is the solution. So these are the three important facts. Okay, so this is just for the theory purpose, because before this, before I want to solve this question very easily, we have to know some basic. Okay, so in the question it is already given that the yt. Okay, now here we can say I am just writing the what we can say the solution from here. In the given thing is yt equals to at plus b e to power minus 2t. So this is the case of a common root problem. Okay, because for the common root problem the solution is somehow like this. Okay, this one is the somehow a common root problem. Okay, so you have to know these three things. Okay, solution for different when roots are different real, then this one is the solution. C1 very easy one, everyone know, I think this one. But for the common one, c1 plus c2 x. Okay, so here it is a time domain function, so at plus b e to the power minus 2t. Okay, so the common root in this case, we can say the common root in this case is our lambda equals to minus 2. So we can write as lambda plus 2 equals to 0. Okay, so this one is the, we can say the lambda plus 2 or lambda equals to minus 2 is the simply the root. Okay, the common root problem. Okay, so now one more thing I want to say. If y double dash plus a y dash plus by equals to 0, so this one is the homogeneous linear differential equation. So now what we can write, instead of this one can also write lambda s square plus a lambda plus b, okay, equals to 0, not by. Okay, is our characteristic equation of a differential equation. Okay, because if why I am writing, because in such problem what we have to do, y dash equals to, we have to say e to the power lambda x, means dy by dx, what we have to say like this, e to the power lambda x, sorry, y, better, sorry, there is a mistake, small mistake I did. To solve such problem, what we are doing, we have to say y equals to e to the power lambda x. Then we are finding y dash lambda e to the power lambda x, and y double dash equals to lambda square e to the power lambda x. So that's why we can write it this. Okay, because y double dash lambda square e to the power lambda x, then y dash lambda e to the power lambda x, and y by. Okay, so after taking this e to the power lambda x, so this will be the characteristics equation. Okay, so this one is the very simple concept. But so now this one is a common root problem, so what we can say, we can say directly, we can write this one as a lambda plus 2 whole square equals to 0. So what we can say, lambda square plus 4 lambda plus 4 equals to 0. Okay, this one is lambda. Once again I am writing 4 lambda plus 4 equals to 0. So now instead of lambda, what we can write, d2y by dt2, dt2. Okay, here is question. Okay, plus 4 dy by dt. Okay, 4 is there, so y term will be also there, so it should be simply 4y equals to 0. So this one is the solution. So the function for the above one, for the above function will be our d2y by dt square plus 4 dy by dt plus 4y equals to ft, because we have to write the differential corresponding differential equation. So the option number 1 will be the correct answer for this. So the thing is that we have to very careful about some theory of second order homogeneous differential equation, and we have to know this formula for common root. This should be the solution. So for the simple one, c1 e to power lambda x plus c2 e to power lambda 2x, but the two roots are different. So when the roots are common, c1 plus c2x, okay, e to power lambda x, it should be t if we think about in terms of t here, but here I am y dash square dy by dx. So then after, this one is the homogeneous equation, okay, this one is the important, okay, this one is the homogeneous equation, second order homogeneous linear differential equation. So the characteristic equation like this, or sometimes it can be also written in terms of differential operator d, differential operator. Okay, so this is the way to solve this one. So common root, just lambda plus 2, right? And take it square because the root are common. So then we have to write like this. 4 here, there should be y. Okay, so y should be there. And 0, so there should be some function. So now we are writing in terms of ft. Okay, so the solution is this option number A. So this is all about this question. So thank you for watching this video.